Hello, I'm Morel from Bosch Research, and it's my pleasure to present our work on a callback group level executor to support mixed real-time critical applications with ROS2. ROS2 basically uses the same computational model as ROS1 with nodes, with callbacks, which are triggered by messages, by timers, and these invocations are processed sequentially by a spin thread. For this purpose, ROS2 introduced the notion of an executor on the RCL-CPP layer, and each process has one instance of this executor that works as a spin thread on these invocations. And as you learned in the morning, it's also possible to put multiple nodes in one process in which one executor will serve those nodes together. Now, we thought about applications where we have different real-time requirements in the same node. For example, an emergency stop callback, this should be processed in any case, even if there are other invocations before. And our approach is to create multiple executor instances in the same process and to configure them the normal operating scheduling mechanisms like priorities, core pinning, or batches. And for this purpose, we had to refine the executor API to work on the level of callback groups instead of whole nodes, and also to use more refined waiting sets on DDS where the actual queues are managed. In addition, we allow for annotations to the callback groups to specify real-time requirements to do this mapping automatically in the future. We did a fork of ROS RCL-CPP and created a new branch where I was given on the slide, so you can download it and try it out yourself. Also, we did some very first experiments. We created a simple application with 2 nodes and 2 paths with different criticality, just sending ping-pong messages around and burning CPU cycles in the Pong node. And our first test validated that this whole stack is working as expected with regard to real-time requirements. That's also a fork of the ROS2 examples repo, again, a branch meta executor that you can try out. Feedback is warmly welcome. Try it out, contact us, and many thanks to William for helping us to dig into this whole stack, for Carsten and my colleague Christina. Thank you.